Okay, so I'm very pleased to have with me here four amazing tech leaders. Mark Russinovich, Azure CTO and longtime proponent of confidential computing and keynote speaker at last year's OC3. Ian Buck, VP Hyperscale and HPC at NVIDIA, the company that is currently pioneering confidential GPUs. Mark Papermaster, CTO at AMD, the company that is pioneering confidential VMs. And Greg Lavender, CTO at Intel, the company that pioneered confidential computing as a whole, if you will. So welcome, everyone. I'm immensely excited to have you here. And yeah, the title of this panel discussion is The Impact and Future of Confidential Computing. And to kick this off, I have a sort of foundational question for you. What actually is confidential computing? And maybe equally important, what is not confidential computing? And maybe you want to start with that, Mark.
Yeah, good question, Felix. So I think what the easiest way to think about it, or the simplest way to think about it, is that it's like protection for data at rest, protection for data in transit, which we're all familiar with. This completes the third leg of the triad, which is protecting the data while it's in use. But more specifically, it is based on something called a trusted execution environment, which is a hardware protected enclave, it's sometimes called, into which you can put code and data that is protected from everything outside of that enclave, whether it's an administrator on the box, a hypervisor, the host operating system, even physical attacks. And that enclave has two really important properties. One is that, besides the protection, and one is that it includes measurement of what is in the box in the enclave, and attestation, which is its ability to provide a verified signature attestation of what's inside the box, so that something outside the enclave can establish trust with the code that's inside and be comfortable releasing keys and exchanging data with it.
Yeah, I think that sums it up quite nicely. So anything else to add here from the rest of the folks here? Maybe also something on what is not confidential computing.
Well, this is Greg. Maybe I can chime in with an analogy I like to use that seems to work well with a lot of customers. Is if you think about the modern infrastructure that we're running on, let's take in a typical cloud. You've got infrastructure as a service. You have, it could be VM as a service on top of the infrastructure as a service, or containers as a service. You might have platform as a service, then you have some software as a service. And so each layers of the software abstractions that are giving us all the advantages we have of the cloud, you can think of the application wanting that guarantee that Mark just talked about with data in use. And I like to think of it as that you were giving the application developer, the application itself, a titanium straw that slices through all those layers of software abstraction and touches this trusted execution environment to allow that application to uniquely read and write secrets in and out of that trusted execution environment, despite all that other software that they don't necessarily have the control over. So it gives a level of autonomy, I think, to the application owner with regard to their secrets that are unique to them.
Yeah,
I'll add that confidential computing also, is coming at a time when there's a lot of dynamic shifts happening in data center. Who buys the servers, who stands them up, who maintains and operates them, who uses them, and actually who develops on them, and who owns the data is all becoming disaggregated. And the need for confidential computing and what confidential computing is enabling is that ecosystem where we can be a lot more flexible with and trust each other of all those different players in the moment. In order to do that, it's about security, obviously, having that trust and building the technology platforms where everyone can rely on that. To me, it's a fascinating pool of technology to allow that to happen. But really, that's what's enabling in the ecosystem is all of those players being different entities, different individuals with different levels of IP, security, and information that they can trust is kept confidential.
And I'll add one aspect of what is confidential computing not doing? You're not handing over to the cloud vendor control of your trusted confidential data. It's what's very paramount is that establishment of the owner of the data actually owning the keys. And I think that's, a fundamental aspect that customers really appreciate about confidential computing.
Yeah, and Felix, you asked what it is not. It is not other privacy enhancing technologies like homomorphic encryption or secure multi-party computation. It is hardware rooted, trusted execution environments.
Yeah, that makes a lot of sense. Thank you. So I think there are a lot of exciting use cases for this. And let's talk about the use cases that you are seeing in your job at your companies. Maybe you want to start, Greg. Is there anything you can share there?
Well, besides obviously the use cases that we're seeing now in the public cloud services, and I give Azure Cloud the credit for being a leader in this space, is at the edge. As people start running these models, whether vision models, other machine learning models, you're outside the traditional security perimeter, and so in the data, both the code and the data is subject to attack and/or theft or disruption. So we see a lot of use cases emerging at the edge, and we think that's going to be a pretty fast growth area as people look at these kinds of use cases, like even privacy preserving capabilities. So you think of like autonomous vehicles, right? They're training on all this driving data, right, in the visual recognition of cars and people and things like this. But when you want to go do learning on that, you want to make sure that you're not violating people's privacy, their facial image, their driver's license plate. And so you want to obscure that data or information or make it inaccessible to other people that might be using that data in their learning models. And so you can tag things in certain ways to make that the case. So I think there's cases in healthcare too, with the sort of home healthcare happening that was driven by COVID, maintaining privacy and confidentiality of the patient data and the patient information at the edge as you federate data and you do federated learning. Those are emerging use cases today that we've already working with customers to prove out.
I would add as well, I just pivot off of Greg's comment, which I totally agree with, that the data itself, not only protecting data of medical records and privacy information, but for AI training purposes, the data itself is gold for many businesses. And so it's an entire new use case as AI really starts to permeate every application, is protecting that data that you're training for advantages that you're offering to the marketplace.
And I'll add another use case, which is, there's the cases like Greg had talked about, which apply to cloud too, right? The processing of that autonomous vehicle recordings in cloud need to be protected. And they're protected from not just the cloud provider, but also the employees of the autonomous vehicle company, which shouldn't have access to that data either. But I think one of the really exciting scenarios or workloads for confidential computing is multi-party computations and analytics and machine learning, where you have multiple parties bringing their data together and what is now being called clean rooms to perform a computation on that data, the computation that they trust, and then get back an answer that is much richer than what they would have gotten off their own data set. Regulatory reasons or privacy reasons or sensitivity about sharing data with other parties can be addressed with confidential computing in that way. And I think one of the places where we see this really taking off is in advertising. And I think it is the future of advertising, where there's so much concern around the privacy of consumers that if you've got a scenario like Royal Bank of Canada does, where they've got a clean room solution where they take merchant purchasing data, mix it with their information around the consumer's credit card transactions to get a full picture of what the consumer is doing, and then can offer the consumer very precise offers that are tailored to them, but without Royal Bank of Canada really understanding what the consumer is doing, without the merchant seeing what the consumer is doing, and then the merchant's data being protected also from RBC.
Yeah, those are great use cases where you log everything out and just have a black box where data goes in and then results come out. Yeah. Anything to add from your side, Ian, on the use case part?
It's been touched on. I think there's obviously a groundswell of opportunity that AI brings to all of these markets: the financial, healthcare, automotive, advertising, as was mentioned. The challenges are increasingly the people who are collecting the data, the people that want to operate and execute on it are different players. In many cases, a large company may want to work with a smaller company to create an AI-based solution who has the AI expertise and bring something to market. By providing a trusted container, a confidential computing enclave, you can trust both sides of that party, as Mark said. And even that the people who are operating and running and touching the data, that trusted environment can make sure that data stays contained, because it's been tested and proven and agreed upon by both parties, and even signed with symmetric keys. So the activation of AI is really, frankly, on the enterprise side, has been inhibited by that, because AI is driven from data. I'm certainly very excited about what confidential computing can do to unlock the capabilities of AI across enterprises and all the different parties that want to get involved.
Yeah, and I'll make a plug actually for what Ian's company's doing and Ian's leading is with confidential GPUs is protecting the IP of the AI models themselves, not just the data that they process. Like if you're doing inference, in the public cloud, the cloud provider shouldn't have access to what's being inferred on. But similarly, the cloud provider and or other parties shouldn't have access to the AI models themselves, which can cost millions of dollars or more to train and are very considered very valuable IP. And that applies to the edge too, when you're taking those models out of a secure environment.
Yeah. So those are great use cases. So let's get maybe to the challenges. What do you see as challenges for companies to adopt confidential computing?
It's the challenges of confidential computing, are similar to the challenges we're seeing in data center holistically. The need for compute at scale, the need for applying AI or GPUs or accelerated computing to reduce cost and to improve throughputs is the same, is feeling it everywhere. In confidential computing, we don't have that technology, at least until recently, to be able to deploy GPUs at scale in clouds with confidential computing. And technology needs to be built for that. And that's what we've been working on with Mark and, of course, with our friends on the CPU side to build a system where two separate devices across a PCIe connection, across the cloud, across the VM, can have all those pieces work together. And we're all making sure that security is everything, and everything's maintained confidential. That trusted execution environment with a confidential container has been made possible only recently. And so getting that technology available everywhere, deployed in every region, and definitely with the help of Azure, who's taking the lead on this, bringing it to market so that wherever the customer has their data, wherever they need to do that computing, that processing, or that deployment of AI, they have access to it. So, one of the biggest challenges right now with confidential computing is just getting access to confidential computing and getting access to it with GPUs. So I'm really excited to be working with everyone here on this call to help bring that technology to market.
Yeah. So maybe go a bit deeper here. So have all the problems been solved already, or do you see also remaining technical challenges that need to be addressed before it can become fully mainstream?
Yeah, I think we made a first step with our Ampere architecture, working with Mark, and now we're taking it to this next step with Hopper, which is coming to market this year. So what are some of the technical challenges that still remain or are still being worked on? We obviously want to make it as easy as possible for developers and users to consume the technology. You don't want to have to write an entirely different kind of code or different code base or minimize the impact to the developer. I believe we have achieved that. There are still some caveats. We're still continuing to like make it a completely as seamless and easy as experience as possible to get access to be able to run the workflows, which probably were never originally designed for confidential computing, into a confidential computing enclave. That's one. I think we've eliminated a lot of those. There's still a few more, and then the remaining is just looking through all the speed paths. If confidential computing runs slower because it has to sign everything or process every bit of data, and slows down critical speed paths either in PCIe transfers, in the movement of data, or the encrypting and decrypting of data from host memory through the VM, you lose the value of accelerated computing. You limit your outcomes or how quickly you can get to your data, and you're in the end probably increasing costs and complexity. So a big part of that has been making sure that we have the right hardware capabilities in the GPUs, working with the capabilities that already are in the CPUs, and as well as the VMs to make sure that we keep the workflow running really fast. For the most part, I think Hopper hits it. Still working with Mark on bringing that to market, but I'm very excited to be making sure it's a seamless experience, both from a developer standpoint as well as a performance standpoint, where there's minimal impact. The fact that everything's being encrypted and maintaining security. And I think Mark and Mark and Greg can talk a little bit more about the more of the details of the technology bits that we've been working on together to make sure that that's true.
Ian, I think that you said it exactly right. When I look at the challenges that we have going forward in confidential computing, first and foremost, it really has to be seamless from a deployment. There shouldn't be any performance impacts. We need to eliminate that over time, and it just should be invisible to the end user. We were very focused as we at AMD first introduced secure encrypted virtualization, SEV, and partnered early on with Azure on its implementation. That it just ran. It seamlessly did not require code modification, and that really lowers the barrier for adoption. And the way that we build out an ecosystem with that is that we align across the industry on how to do that. We've partnered with Azure on how to open up from secure confidential VMs to make sure guests can operate with those VMs, with the CPU VM, and still operate under that confidential compute umbrella. And to that end, we need to come together and are coming together as an industry to extend that confidential compute boundary out through end devices. And I couldn't be more pleased than how we've come together the last 3 years with protocols, working with the industry standards body, the PCIe SIG, which has just been around for years, such a well-established consortia, to work on the establishment of a standard that extends to I/O. It's the TDIST, the TEE, device interface security protocol. And with TDIST, we're going to be able to really extend to whether it be smart NICs and I/O endpoints, have a standard way in which we extend that umbrella. And then, lastly, early on, Mark talked about attestation, and Greg commented as well. Attestation is where you really trust the device that you're attaching to. And I'm extremely pleased how the industry has come together on open standards with Calyptra, so that we have a very transparent way, an auditable way, in which each manufacturer establishes that credibility of the device origin. So very, very exciting developments that the industry is coming together on.
Yeah, not just add, I think I agree with everything said here, and it's just continuous maturation of the technology. But I was actually in New York back in January, and I spoke to about 100 CISOs, and I think only about 6 of them had ever heard of confidential computing. So I think we have a lot more to do, and I mentioned this in the keynote I did for this conference, that raising the awareness of CISOs, of CIOs, of policymakers, particularly within the government and other regulated industries, to get the adoption driven and demand the technology from all of us that are supplying it. And that's going to help a lot. And then we also have to keep our eye on the next technical leap, like CXL, right? Make sure all of our confidential computing environments have quantum resistant crypto capability as we get the standards defined and get that into our products. So I think, we have to keep pushing the envelope to secure that data in use trust boundary. And we've all talked about disaggregated architectures and how, whether it's the interconnect, PCIe, CXL, what the devices are, the heterogeneous devices, because people are building everything at clusters, very large cluster scale now. It's not about a single node or single device.
Yeah, and I think actually, Felix, when you talk about barriers to adoption, a lot of the big ones have fallen just in the last 12 months, and we're seeing more fall over the next 12 months. Like Mark had said, we didn't have the ability to run off-the-shelf operating systems until SEV SMP came along, and that has made it so you can lift and shift workloads and make them confidential rather than go and develop on custom OSs and library OSs, which you had to do prior to that. And then, like you said, we've built confidential containers in Azure capability on top of that, which allows you to take lift and shift off-the-shelf container images and run them confidentially. But the other thing that has also happened is just the maturation of the foundational services that support confidential computing, from everything from the work that we're all doing together in the Confidential Computing Consortium, CCC, on standards and things like Open Enclave SDK, to the standards we're driving with OCP, that, like Mark just mentioned, to the development of services in cloud providers like ours, and what Intel's developing around attestation services that make it easy for developers to validate reports coming out from the hardware, to PaaS services that are built on confidential computing, like our SQL Always Encrypted service, which allows you to run your SQL database inside of an enclave and give you assurance and protection against operators of the Azure database and anybody else that might infiltrate the infrastructure in Azure. And all of that Kubernetes pods we can run confidentially now, which we couldn't do 6 months ago. So it's just, this is really a takeoff year, I think, for capability that is starting to really make it easy for enterprises to adopt confidential computing.
Yeah, absolutely. Okay. Great development. Let's talk a bit more about the future. What's lying ahead, and maybe Mark, what's your vision of the confidential cloud? Everything always encrypted, end to end, or will it be more like specialized services?
So when we talk about confidential cloud, we're really referring to pervasive confidential computing, and I think Ian mentioned it earlier when he said, "Hey, there shouldn't be any compromise. You should just be running confidentially." Even if you haven't defined what we're calling a confidential trust boundary for what services are touching the data, you get a defense in depth of protection from confidential computing. But when you really architect a service or services that are interacting together to say, here's how the data is being protected everywhere, and here's how the services are validating that the data is protected, and it's going to be protected if they hand it off, that is what we're really referring to confidential cloud. So every server, every virtual machine is confidential computing. We've got confidential PaaS services. We even got confidential SaaS services. And there is end-to-end attestation and protection of the data through its entire lifecycle. And that's just, we talk about I mentioned the third leg in that triad. The first two, we just take for granted now. Nobody even talks about it. It's just an assumption you're going to have encryption of data at rest and on the wire. And I think in 10 years, that's just the way. It won't be confidential computing. It'll just be computing.
Yeah. That makes sense. So let's talk a bit about attestation. I think attestation is one of the killer features of confidential computing, and I hope you agree. But what I see often is that it's difficult to make attestation accessible for the end user, right? Users are used to TLS certificates maybe, but it's very difficult to somehow make this accessible to end users. Do you see a way how this could be done, how this should be done? Or is it maybe something that should be hidden from the user all the time? What's your take on this, Greg?
Well, I think attestation is a way to get sort of proof of trust. So we're advocating. Okay, here's this confidential computing environment. It's got this great hardware. It's got capabilities that we can all bring to bear on behalf of the customer's environment, their application. So it's like, but how do you know? So you've got to have some, and many customers, particularly regulated industries, will have sort of strict compliance, security compliance, policy compliance, et cetera. So if you think of the attestation service, in some sense, you bring in a policy to say, for example, I want to know that on this node I'm running in some public cloud or in some data center, that the firmware is up to its current patch level. There are no outstanding CVEs on the BIOS or some element of the firmware. So you should be able to say to the attestation service, which should be a SaaS-based service with API-driven, so applications can call it, not necessarily users directly, and ask for a proof of that state of the trusted execution environment in the host in which it's all running, and get that record back and have that record sort of properly committed in a non-repudiated way, so that you have a proof of that, and the frequency in which you get that record reattested, that environment reattested, is going to depend on the application. It could be every time the machine reboots. It could be once an hour. It could be if there was a firmware update, then I want to know that it's compliant and boot back up to that environment. And with all the work going on, in which Mark Russinovich and myself and others are involved in, is the software bill of materials. You'd like to know as well, but all the software that you're running and what's running in that trusted execution environment, the provenance of it, that it's not been tampered with. And even at Intel, I have this concept I call chip to motherboard. We can give you the birth certificate of a chip off a wafer, right? Since we produce our own wafers in our own factories, all the way to the motherboard that it was put into and all the component parts that went along in the supply chain to achieve that. I don't want to call it the H-bomb because that's the negative term, but it's the hardware bill of materials. So I think, if you can enrich the attestation record to be not just a software bill of materials and a trusted proof of trust for the environment that you're running in, but I can give you the birth certificate and all the times that chip was in the supply chain and what happened to it, so that when you assemble that motherboard in Azure cloud or any other cloud, that you have sort of that full record of what it is that you're using. That's the dream of the United States government and any other government doing a sovereign cloud. And I think that's not where we are today. We're still at the very beginnings of this. But I think the opportunity here is immense.
Yeah, we've had to, one of the big challenges, right? The ecosystem of confidential computing is growing. We talked about smart NICs, and we talked about motherboards, CPUs, and of course now GPUs. So giving those customers trust that all the components have been properly signed, what their state of the world is, and they can trust, and ideally in a way that is largely seamless. So I do know that NVIDIA has a presentation actually at OC3. Our Mark Overby, our Chief Platform Security Architect, is giving a talk about explaining how attestation works with GPUs. So I encourage your audience to check it out.
Yeah, to add on to what Greg said about what we consider code transparency, which is critical for confidential computing, where you're letting somebody else's code into your confidential trust boundary, is that you want the ability for that code to be audited. And that means precisely what is that code, which I think brings in things like reproducible builds, where you can take the source code and produce the final artifact, especially for the core parts of confidential computing. It's really important. And so we're starting to build out that foundation for code transparency, which includes the supply chain and software bill of materials work. And I think that's another place where you'll see this start with confidential computing, where it's essential to the trust that we're establishing, but then move into mainstream software supply chain. And again, it might be a decade or 2 decades before everything is developed that way. But we will SolarWinds type of problems. I think we'll have a much better place to mitigate them and address them and identify them once we have this kind of transparency in the supply chain.
I'll make the point as well that the attestation service is itself a confidential computing application.
Yeah, I think
yes, that's crucial.
What's interesting for listeners to really get excited about is we're building a whole structure. It starts with that root of trust, where you have confidence in the device, And then all of the comments build on that. You just start working your way up the stack as we proceed and we implement into mass deployment, where you not only have the identity and the history of the different components, you basically then have a trusted supply chain. And then Mark, as you talk about, all the way through auditable code and applications. I mean, it is really going to be game changing in terms of being able to, put a halt to these, malicious attacks, which we read about in the media each day.
Yeah. Okay. And super interesting points. So let's, if we take a look into the future again, when do you think we will see like maybe 10% of workloads using confidential computing? When maybe even like 50%? And will it become something like a must-have, like antivirus? And what do you see maybe as the biggest potential impact? You want to start, Mark P?
Yeah, I think mass adoption of confidential compute is simply inevitable. I mean, you have to trust that your data and your applications are secure. And so as we as an industry come together and create the constructs to lower the barrier to adoption, to make it seamless, to make it be, virtually no impact over time to your performance, it won't be a different offering in your cloud instance. It will be the default. I think it's really paramount. And again, I just think it's tremendous to see the industry coming together to accomplish that goal. How long will it take? Mark R. might have the best guess in terms of rate and pace of adoption. But I think as we lower the barrier, it'll be quite quick. Mark?
Yeah, I think it'll be quite quick. Like I said, this past year and this next year are significantly lowering the barriers and paving the way to mass adoption. So I think we'll get to 10% within the next 2 to 3 years.
What do you think, Greg?
Well, I think
adoption and biggest impact.
So I wear multiple hats here at Intel. I'm the CTO, and turns out I actually have all of IT reporting into me as well, because I treat IT as just another engineering function in the company, since we're a deep tech company. And so the CISO reports to me. In fact, I did a briefing meeting earlier today where I had my confidential computing team together with my CISO and his team talk about IT as customer number 0 for our confidential computing platforms. And so going through all the places within our IT infrastructure globally, and including our factories and our fabs, about how we could basically bring confidential computing, into the production of these chips, given all the security concerns people have about supply chain. And the thing that I realized that I actually is, so I'm sort of acting as the CIO, even though I'm the CTO. I'm going to start putting in RFPs for any technology that goes into our data centers and into our factories. Not right away. I don't want to panic all the vendors, but I'm going to start writing into the RFPs for the technology we source that they must have a confidential computing option. And that will start driving the software industry to do something.
Yeah, I think we need to get the ubiquity out there, and that's important. Like Mark said, I think it'll be next 2-3 years, definitely 10%, but it could inflect fairly quickly. I mean, if you think about it, at least I can remember when everything was written on the internet with HTTP : and then one day the world changed to HTTPS : and there was a lot of things that had to happen to make that work. And today it's ubiquitous. No one even bats an eye. In fact, if they try to give me a link to an HTTP, I can't do it. That's that whoa. So that transition took some time, but when it happened, and it really there was enough ubiquity and momentum, it went from 10 to 50 to 100 pretty darn quick. So I can see that happening here with confidential computing. It'll take the initial few years, I believe will be the 10%, just because we don't have the access. We got to continue to work out the kinks in performance and capabilities and ubiquity. But after that moment, I believe it will flip over fairly quickly.
Awesome. I love the HTTP analogy. That's great.
I'll just add one concluding comment from me, which some of the other people have already said, which is how awesome it is that we're all getting together as an industry to push this forward, and really collaborating deeply, and doing it in standards bodies and in the open as much as we can. It's fantastic to see, and this panel right here is a testament to that.
Absolutely.
Yeah, and I agree.
Yeah,
It's an industry. This isn't where we have to have competitive fights. This is table stakes for the whole industry, and we just have to work together to achieve it in a heterogeneous way.
That's right. It's like I commented earlier. You have to have trust. Our customers have to have trust. If they don't have trust, it damages all of our business propositions.
Yes. Okay. Then thank you, everyone. This was amazing. Thank you so much for your time. And yeah, we should do this more often.